Hi everyone. So we are going to look at experiment number 2 from the syllabus, which as you can see it is the familiarization of scientific computing, and we'll be looking at these three questions, basically functions with examples, basic arithmetic functions using absolute, sine, real, image, complexing, extra using built-in modules, and we'll also look at something called as a vectorization. Okay. So uh, let's start with the basic functions. So we have already seen there was a lecture which was conducted for how to uh, use or how to implement a function and how we can use the functions to avoid repetition, etc. etc. So this is one such sample code where we are trying to demonstrate the use of function. Okay. So as we know, the function has start with def. There's a function name. So this is the function name, and then it will take arguments. Num1, for example, in this case, our arguments are num1, comma num2, and there is a function body. So basically, whatever you write inside this is called as the function body. Okay, and once you write in the function body, then you can return some values from which the call is being made. So here I have written two functions. The first function is called as getSum, and second function is called as get quotrum. Basically, the first function will return the sum of two numbers which is being passed, and the second function will return both dividend, both quotient and the remainder. Okay, we'll see the elimination one by one. So when you run the code, since these two are functions, it will not be directly executed. It will be executed only when these functions are called. So the execution of the code will start from here, wherever it is not defined as a function. And remember, when you define the function body should be at one tab space. Basically, whatever is here, this is one tab space. One tab space apart from the start of the def keyword. So whatever is inside this one tab space is the function body, and there should be a semicolon after the def, the function name, and the argument list. So this whole thing will be one function. The interpreter of the Python language will take this whole thing as single function. Similarly, for the second case, I have the whole function this one. So whatever is written in this part from line number 12 to line number 16 is under the function get quot run. So after this return statement, I don't have any tab space, which means whatever is written after line number 16 is not in any of the both function. It is a standalone code. So the execution of the code will always start from this standalone part. Okay. So if you want, you can write this function inside here. Okay. It doesn't cause a change because this function will be executed only when it is called, only when the get some function is called. And so we will look into it later. Okay. So now what is the output of this function? So initially I declare a variable val1 which has value 3. I declare another variable val2 which has value 4, and then I'm calling getSum with values val1 and val2. So val1 is 2 and val2 is 3. So once this call is made, the execution will go here. So num1 will become 3 and num2 will become 4, and num1 plus num2, which is 3 plus 4 equal to 7, that will be returned. It will return to sum bar. The sum bar will be 7. Now, in the second case, I change my val1 value to 10 and val2 value to 3. And I am calling get quot run. So val1 value is now 10, val2 value is now 3. So when the get quot run is called, the dividend value will be 10 and divisor value will be 3. And then inside the function, which is basically this function body, I am dividing the dividend by divisor and finding the quotient. The double slash gives the quotient when the left operand is divided by the right operand. This gives the quotient. And I am also getting the remainder by dividing dividend by divisor. So the operation is percentage. So if you have a percentage symbol between two operands, it will return the remainder when first operand is divided by the second operand. So that is enough. Now if you compare this function and the function above this, you see that in the first function you are returning one single value. Num1 plus num2 is one single value. But in the second function you are returning two different values. So you can return any number of values from the function. So here when you return, you are returning two values and the value of the quotient will be assigned to Q and the value of the remainder will be assigned to R. Okay? I can have any number of values. For example, I can define a different value here and return from here. But in that case, I should, wherever the function is called, I should accept that's what number of variables. And you print the function, print the values. Okay. So if you go and execute this, so you see that the first one, the first print statement gave me 7 and the second print statement gave me two values 3 and 1 because when 10 is divided by 3 the remainder is 1 and the quotient is 3, so that is being printed. Okay. So this is the basic stuff about functions which we have already seen in the previous class. We have a training on functions. So this is to just to give an overview of how to use functions. Okay. So coming back to the second point, using the basic arithmetic functions such as abs, sine, real, image, complex, sync, etc. using built-in modules. So using Python, let's say I want to find the sine of a number. If you are using a calculator, you have a sine function. You can press sine and you can give the angle in radians that will give the sine value of that angle. So how will you make use of this property in Python? So for math functions, you have something called as package. There's a package called as math. And you should import this math package to make use of all the functions inside math. So this math package have all the sine, cos, absolute, real, complex, all these functions are defined inside this math package. So I am importing this math package as m. So wherever I need to use math dot something, I use m dot something. So if you look at this scenario, you see that there is a I use, let's say I am defining an angle. The angle that I am defining is, let's say, pi. So pi is already defined inside math. This pi value is like 3.14 something something. Okay, that is already defined inside the math package. So since I am importing math package as m, then I use m dot pi. Let's say I'm not using importing as m. Instead, I'm just say import math. So in that case, you can just directly write math dot pi. So I am importing as m, which will allow me to use, instead of typing the whole math word, I can just type one single letter and use it. Okay. Now I want to find the cosine of this angle. So this cos is defined inside the math package, which is imported as m. So if I do m dot cos in with the angle inside, this will return me the value of the cosine function at this angle, which is now pi. Okay, and remember this angle should be in radius. which will give you the correct result. Similarly, if I want to find the sine of an angle, I can just say m dot sine of the value of angle. Again, this angle should be in radians. Okay. Next, I'll just print the values. For example, I want to know what is the value of this angle. So I can just print pi. Since angle is a floating point number, I cannot print directly along with a string. I'll convert this angle to a string and I will concatenate with this one so that I can print in a single line. Okay. Similarly, I'm going to print the cosine value of this, which is cos angle. I'm also going to print the sine value of this, which is basically the sine angle. So if I now do my, so you see that the pi value is 3.1415 the whole range. The cosine of angle, which is cos of pi is -1. And you see sine of phi should be 0. But here it is showing some value. Actually, this is almost equivalent to 0 because it is 1.22 into e raised to -16, which means it is 1.22 into 10 raised to -16. This is a very low value. Okay, so this sine value not reaching to 0 is because of the truncation error. Okay, so but this value is very small, so we can consider this as almost equal to 0. Now this is by giving a single angle. Let's say I want to keep on giving values to that. So what I can do is I can create a for loop for angle value in range. I am starting my value from 0 to pi by 2, m dot pi by 2. Okay, and then I am saying print m dot cos angle of angle value. Okay, so let me make it a higher range. Let's say this is 4 pi. So what it does is for each iteration, the angle value first will be 0, next will be 1, next it will be 2. So the angle value will be 0, 1, 2, 3, 4 up to the integer part, the integer value of 4 into 3, which is 3.14, which is the pi. Okay. So each time in each iteration, the angle value will change as integers 0, 1, 2, 3, 4, etc. etc. Okay. So if I print this, so let me comment about this one. So if I print this, so right, the for loop should have a semicolon column. Sorry, so this should be an integer. So I'm just rounding off. And this is cos. You see, you can see that at angle value is equal to 0, it is 1. This is the angle value when it is 1 radian, 2 radian, 3 radian, 4, 5 radian, 6 radian, 7 radian, 8 radian, 9 radian, 10 radian, 11 radian, and 12 radian. So all these are different angle values. So in a loop, you can print out all these angle values, and we'll see in one of the later experiments, we can also plot these values so that we can actually see a sine curve. Okay. Now, apart from doing all this operation with the sine function, I can also do some product operation. For example, if I define angle is equal to m dot pi or m dot pi by 4, just for the sake of completeness, okay, and I can say the product of sine cosine is equal to cos of angle multiplied by sine of angle. So basically you are multiplying, you can multiply any kind of this uh, trigonometric function to give you the product. So if I print product sine cosine, you should get, sorry, this should be m dot because we are using the package. You see, which is 0.5 cos of pi by 4 is 1 by root 2, sine of pi by 4 is 1 by root 2, 1 by root 2 into 1 by root 2 will be 1 by 2, which is 0.5. So when you can print this one. Also, if I, let's say I want to take a power, or you want to multiply m dot cos of angle, let's say I want to take the fourth root of this, or fourth power. So this is basically, it is saying that you are taking cos of angle raised to 4. Okay, and if I print this, you see that it is 0.5 raised to 4. This 1 by 2, 1 by root 2 into 1 by root 2 into 1 by root 2 into 1 by root 2, which is 0.25. Okay, so you can do all these operations with the trigonometric functions in your using the Python. But the important thing is you should use the math package, and you should import the package and use math dot or whatever you are assigning to. Okay, so that will, so so that will give you an idea of how to use trigonometric functions using Python. Now, similar to trigonometric functions, you can also use Python to calculate complex values. Okay? There are two ways to do this. I'll demonstrate both of them. In the first way, I am defining a complex number. So you can define a complex number by saying the real part plus or minus some real number with a j. So whenever you say j, it means it is the imaginary part. Okay. So if I print this, if I print a complex number, you can see that it is printed as 1 plus 1j. It has taken as already as a complex number. You can also print its real and imaginary part. To print the real and imaginary part, you take the name of the complex number, the variable, dot real will give the real part, and complex number dot image will give you the imaginary part. So it is 1 plus 1j is, real part is 1 and imaginary part is also 1. So what about if you want to do complex multiplication? So let's say I define one more number, complex num 2 is equal to 2 plus 2. If I want to do complex multiplication, you just need to do a symbol multiplication in Python. So you do this. Okay. If you print the value, you can see that it is actually 1 plus 1j into 2 plus 2j is 1 plus 1j whole square multiplied by 2, which is 4j. So actually, if you are using C or C++, you need to take out each and every number. Then you need to multiply in a loop one number with the real part of the other number, the real part of one number with the imaginary part of other number, the imaginary part of first number with the real part of second number, and so on. But in Python, it makes more easy by just doing the complex multiplication. You can, by just doing a normal multiplication, you can also multiply the complex number. So this makes it easier in Python to handle mathematical operations. Okay, so there is another way also to do complex thing. So for example, you can define any number as complex like this. Complex is a keyword, is a function, and you pass the real part and comma the imaginary part. So if I print this now, you see that it is 3 plus 2j, which means it is taking 3 as the real part and 2 as the imaginary part. And you can do the same mathematical operations that we have discussed before, like real part, imaginary part, addition, subtraction, multiplication, division. All these operations can be done. Okay. Okay. Now the next thing is there's a function called as sing function. I don't know whether you have studied this. It usually comes by in signals and systems where it is a very important function in communication. It's called as a sing function. The sing function is defined as sine pi t by pi t. Okay. So sing of t is equal to sine of pi into t divided by pi. This is the sing function. It's a very important function. You can find the value of the sing function in Python, but for that you need to use a package called as numpy. It's a very important package. So there's a package called as numpy. We'll be using this package very extensively in our experiments. So using this numpy package, you can find the value of sing. For example, I have imported numpy package as np. So I do np dot sing is a function already defined in the numpy package. If you give the value in radian, you will get the corresponding value. So if I do this, let's say I do this because, sorry, you see you get a value. So using different types of functions, you can also find you have different functions available in your Python by using the package math and numpy to find out the different operations in different functions. Also, I forgot to mention regarding this function in complex numbers, which is called as absolute. Okay, so if I want to find the magnitude of this complex number, I can just say m dot of plus number. You can import both the packages simultaneously. It will not be a problem. So there is an indentation error. So I need to put this. So NP numpy package has this ABS value. which means the square root of real square plus imaginary square, which is root square root of 1 square plus 1 square, which is root 2, which is 1.414. So you have any number of functions available using Python. So all these things you can get it online also. So if you just search in online, you can just say uh, mathematical functions in Python. So you get a lot of documentation regarding the mathematical functions. So always the net is internet is always with your help. You can see a lot of functions and explanations for each of these functions. You can make use of all this. So this is the official Python documentation where you can see using the math package what are all the functions available. The factorial function, GCD. So you can just read through these documents and you will be able to find out all the functions available to do any kind of mathematical operations using Python. Okay. So next we come to something called as vectors. So before start explaining the code, let me show you mathematically what a vector is. So you might have already studied in max the vectors. Okay. So let me say what a matrix is. So a matrix can be defined as you can have multiple rows and columns. For example, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 3 by 3 matrix. Okay. Now if it has only one row, for example, 1, 2, 3. This is called as a row vector. Or if it has only one column, let's say 1, 4, 7. This is called as a column vector. Okay. And this is important because many of the complex operations can be reduced with increasing performance by using vector notations. Okay. So vectors, we can also implement vectors in Python. Okay. So you might have studied something called as arrays in C or CPT, where you have an array defined as something like this: 1, comma, 2, comma, 3, comma, 4, which means it will occupy continuous memory locations in your RAM, right? This is it. Similar to arrays, we means Python have lists. Okay, this is exactly similar to arrays. Only thing is in arrays you can have only one particular data type. This can be only one data type. For example, it can be either integer or float or character. But in list you can have any data type. We are going to see an example of the list so that you will understand it better. Okay. So coming back to this program, so in this program you see I am using a list. So this is the first list which has values 1, 2, 3, which is exactly same as that of an array. I have second list which has values 4, 5, 6. Okay. So you can always populate these values using a for loop also. So in this list, if I run this code, you see that it says the list which is printed here, and the list 1 is 1 2 3, the list 2 is 4 5 6. Okay, you can always populate this list using something like this: for I in range of 0 comma 10, list, let's say 1 2 of I is equal to, and if I just say print list 1 2, and if you run this, sorry, I forgot the comment. I need to define this list as, and instead of doing this, I need to do something else. Append. So you see that appending means we are just adding. So initially I am declaring it as an empty list, nothing is there. And so inside the for loop, I am just adding or appending each value to this empty list. So in the first iteration, the I value will be 0. So 0 will be put into the list, which is this one. The second iteration, I value will be 1, and when I append 1, it will be included into the list along with 0, which will be 1. In the third iteration, the I value will be 2, which will be added or appended to the existing values, which is 0 1. It will be added with 2, and so on till 9. Okay, so this is how we can populate the list in uh, in a loop. Okay, now problem with this one is, like, let's say I want to add two values, add list 1 and list 2. Okay, so I can, if I could have done this, let's say list 1 plus list 2. Okay, so let me comment this. So by just adding these two, we can add both lists. But only thing is the size of the list should be same. But what if I do multiplication? Will I be able to get an correct value? No. It says can't multiply sequence by non-end of type list. So if I want to do some kind of a multiplication operation, I can't use this kind of list. But in mathematical terms, you might need to have multiplications, addition, subtraction, etc. etc. So if you look at list, this is actually a 1D array, which is equivalent to a raw vector. And this list 2 also is a 1D array, which is equivalent to a raw vector. Instead of using this list, there is another option which is available in Python, which is called as vector. And for this one, we need to import this package, which is numpy. Okay, so let me uncomment this first. Okay. So you create a list first, which is, let's say 10, 20, 30. In list 2, I created in a different way. So the first one is actually a row vector, and the second one is actually a column vector. You see the difference. There is only two square brackets, and there is elements within these two square brackets. In the second case, you see that there are two square brackets, and within the square brackets you have multiple square brackets, open and close. So this gives that it is a column vector. And then if you want to make it as a vector, you need to do np. Np is from here, we have imported numpy as np. Np dot array. Array is a keyword or a function uh, in np package of list 1. Okay, so this call will convert list 1 into a vector. Let me run this. Save this. You see that when we printed list, there was a comma after each element. But in this one, there is no comma, which means this is actually a vector. Okay. And if I print list 2, you see that it will not be printed in the same line. Instead, it will be printed one by one. So this is the first one is a row vector and the second one is a column vector. So why do we do this? What is important? Let's say I want to multiply these two. Okay. And I can just do list 1 multiplied by list 2. So if I do that, sorry, there is an indentation error. If I do that, so you can see what has happened. The 20 gets multiplied with 10, 20 and 30, which is 20 into 10 is 200, 20 into 20 is 400, 20 into 30 is 600. 40 gets multiplied by 10, 20 and 30. 40 into 10 is 400, 40 into 20 is 800, 40 into 30 is 1200. Similarly, 60 got multiplied by 10, 20, 30 like this. So if it was a list, normal list, then you could have run a for loop, access each element in the list, multiply the corresponding element in the next list, and you should print the output. But if you do as a vector, you have a lot of advantages. The first and main advantage is multiplication is very easy, and there are many more advantages which we will see later.